A service mesh can give you additional functionality. So it can give you security, it can give you observability, and it can also enhance your traffic management. Today, we are going to taking a look at the first two things, security and observability. So how can we achieve that? The first thing we need to do is we need to roll out Istio in our cluster. I'm doing this with Terraform. Everything is already applied for the sake of this video. So it needs some resources that need to be spun up. And this is basically the Istio CNI node, the daemon, also the so-called Z-tunnel we will take a look in a minute. And then for observability, we are getting Kiali. So Istio is now running on top of Kubernetes. The next thing we are going to do is we want to roll out something in our example namespace. And for this, we need to label our example namespace. We are doing as like, yeah, thank you, like this. So what is it actually doing? We are now setting the Istio injection label and we are removing another label. This will mark the example namespace for Istio sidecar injection, and we are now rolling out our application. So let's take a look into our nifty K9S, what's going to happen. So we see that two applications are spinning up, Callie service and person service, and also a database. If we take a closer look here, what's happening inside, we see that there is an application and also we see the Istio init and the Istio proxy. So what's actually happening now, that for every pod, for every application that we're spinning up, there is also a sidecar, a proxy that is provisioned along. And this sidecar gives us extra functionality with the price of resource cost. So it takes a while for the K9S to pick up to show this, but usually the sidecar consumes about 50 megabytes of RAM and half a CPU. Okay, so what we will do now, we will create some load testing here, some requests here, and we are now taking a look at the observability. This is managed by Kiali, which is the dashboard of Istio, and what we have now here is a so-called traffic graph. We will enable the traffic animation, we will enable the security checkbox here, and now we see already something very nice. We can see the data, how it's traveling through the system. So we see that our person service is communicating with our Callie service, and we also see the connection to the Postgres. And if there would be an error, this would be indicated by red, but we can see everything is fine, and this is green. Very important is this log here. This log shows us that we have end-to-end MTLS encryption between the applications. This is done automatically. So MTLS means we have a client and server certificate in place, and the transport is encrypted and there is nothing we need to do for this. This is taken care by the sidecar. For the observability, we can even go deeper. We can dig deeper. So we can take a closer look at our application. So let's take a look here. And we see that we get a lot of logs. We can take a look into the logs. We get some metrics here for the traffic that is traveling through the application itself, for inbound and for outbound. If we would have traces enabled, which we are currently not, can also see traces here by things like Grafana Tempo. And we also see the JVM metrics itself. This is all very nice, I guess. Okay, so what we can already see with Istio, we get the transport encryption and we also get the increased observability. Still, there is one downside, and this is the cost of the proxy. So we now are seeing here our application consumes only 57 megabytes of RAM because it's a native application, but the proxy on top is owning nearly the same amount of memory. So now it's the question, can we do something about it? Yeah. So what we are doing now instead, we are setting another label. So we are setting the label Istio data plane mode equals ambient, and then we will re-roll out our application. Apply. And we should already see a big difference. So the application is now spinning up. And if we take a look here, it's only the application. And it's not the Istio proxy anymore. So the Istio proxy, the sidecar is not getting provisioned anymore. So this takes a moment until it connects to the database, of course. So we still have the database init container here. And now it's getting ready. Yeah, application is spinning up. Terraform script should be done in a minute. And so now what we can do is we can redo our load tests again. And we can again take a look at the traffic graph. And surprising enough, even without the sidecar, we are still getting the same experience. So we have our traffic graph here. We still see our logs that indicate that we have encrypted traffic here. And we can also still go down into our applications and take a look at the GAM metrics and the other metrics. So it's all still there. And again, it's all still there without a sidecar. Yeah, thanks for that. The autoscaler just has spun up another pod here. So that's what's really happening. Okay, so that is now all very cool. There is yet one more thing I'd like to show you. So the question is the encryption with the logs. What does it mean exactly? So the standard mode that Istio is running on is that it allows non-encrypted and encrypted traffic, which is something we might not like to have. So this means if we spin up another pod like curl, so we see we are spinning a curl pod, which is basically a busybox in the default namespace. And imagine we don't have network policies, which we should always have. It will be possible to do a curl request to our curly service from our default namespace. The default namespace is not part of the mesh. And in this case, we usually would not want that anything or any attacker can connect to this. So what we can do, we can change the mode for MTLS from the default permissive to strict. For this, what we can do is can apply this YAML file here. Thank you. -f. It will be applied for multiple namespaces, but the important one is here for our example namespace. And we now see the mode is now strict and not the permissive as we have for the other namespaces here. If we now do the curl again, what we will see is connection reset by peer. So as we are now in strict mode and the default namespace is not part of the mesh, we are efficiently locked out. This is also true if an attacker would, for example, hack your host machine where your Kubernetes is running, he can also have no access. So with this, we can effectively lock out any attacker. And of course, if we remove our configuration here, -f MTLS, do the curl again. So we now are back to the more permissive mode. We can connect again. Okay, that's already it. Thank you so much for joining me, and I hope to see you in the next video. Bye.